So we are continuing with the same problem. We are doing question 9. So we are saying here we want to find the x-coordinate of the centroid. So now we have to substitute the value of y. So in order for us to substitute the value of y, we have two graphs, right? So if we can see a sketch of these two graphs, y is equal to x squared. It's a graph like that goes like this, and then y is equals to 8 minus x squared. That means when x is 0, y is 8. So it's a graph that goes like this. It's a graph that goes like this. So this is y is equals to x squared. This is y is equals to 8 minus x squared. So we are looking at the centroid bounded by these two graphs, right? Bounded by these two graphs. So when you're looking at this is the upper graph, this is the lower graph. So here you're going to do the same concept. You're going to have 8 minus x squared minus the lower graph, which is x squared, right? So this will be dx over the integral from minus 2 to 2 of y. Y again is the same thing as the upper graph, which is 8 minus 8 x squared minus the lower graph, which was x squared dx. So by this way, you're going to find your x coordinate, and your y coordinate is going to be y squared. So we have y squared here, so it's going to be the square of the upper graph, which is 8 minus x squared minus 8 squared, right? The integral from negative 2 to 2 dx, and then over this, which is going to be the integral of 8 minus x squared minus x squared dx. So you by using these two formulas, you can find the centroid, but you have to be careful. We have two graphs, which means the value of y will be split into two. The value of y squared will also be split into two, right? So you should be very careful at that. And when you're splitting the value of y squared, you're splitting it with the squared for each graph. And also when you have the sketch, it's kind of easier for you to see which graph is in total, because this one is y is equals to x squared, this one is y is equals to 8 minus x squared. So you can see that this, if you're looking at this region, in this point, we found this point, right? And also this graph continues this side, which means they also intersect here. So this is the entire region actually. This is the entire region that we are looking at. So from here to here, this is 2, this is negative 2. So you're looking at this entire region. So that entire region, the centroid of that entire region can be found by finding the x and the y value. So it's somewhere here. So that's it about centroids. This was just a continuation of the other video because there were technical issues. And okay, let me also do the reduction formula for this one for tan. Since we did sine x, which is the same thing as cos, the same procedure, but for tan is a little bit different. How we find how we can evaluate the reduction for tan to the power n. So for this one, if we are saying let in be equals to the integral of tan nx dx, so here we can also split this, but we are going to split this as tan n minus 2x tan squared x dx. We are just factoring out of n, we are factoring out 2. We are factoring tan squared x, sorry. So n minus 2, right? So we know that tan squared x is equals to what? Is equals to sec squared x minus 1, right? So that's what you're going to substitute here. So in is equals to the integral of tan n minus 2x of sec squared x minus 1 dx, right? So here we just so this will be tan n minus 2x sec squared x minus tan so this is still the integral minus tan n minus 2x. All of this is what? All of this is dx, right? So what are we going to do here? Let me just write this as tan n minus 2x sec squared x dx minus the integral of tan n minus 2x dx. So now we are going to use a substitution. So u is equals to tan x, and then du is equals to what? Sec squared x dx, right? So now from this one, this is in, remember, this is in. So now in is equals to this is u, so u n minus 2, and then this is what? This is du, right? From the derivation. So this is going to be du minus the integral of tan n minus 2 is the same thing as n minus 2, right? So this is going to be n minus 2. So, this was an integral, remember, just substituted this and this, but that was an integral. So from here you can further simplify this to be this is going to be u n minus 1 over n minus 1 minus n minus 2. If you integrate this, u plus 1 to the power divided by the new power. So this is what we have. And then remember that u is what? U is tan x. So in is equals to tan n minus 1x over n minus 1 minus n minus 2. So this is the derivation of the reduction formula for indefinite integrals of tan to the power n. So this is what you're going to have. So in the next video, I'm going to expand more on the reduction formula, looking at the definite integrals and how you can evaluate the iteration of that and so forth.